closer we look to the centers of galaxies, the more we find these black holes, and the inventory is rising high. So any idea for the formation of a galaxy will now have to include some explanation for how you get a black hole in its center.
But how did every big galaxy in the universe end up with a giant black hole in the middle? To understand, go back to the very beginning, the Big Bang. Matter and energy rush outward as the universe expands.
So you got the Big Bang handing you your birth ingredients, your hydrogen, your helium, your traces of some other elements. So it's kind of like this soup. You put it together and stir it.
It's gravity that stirs the soup. Over billions of years, it molds the universe into a spider's web of gas and galaxies. Within this web, gravity draws together wisps of hot, primordial gas. Over tens of millions of years, the clouds of hydrogen gas coalesce, growing more and more dense. Some grow hot enough to ignite. The first stars are born, giants, hundreds of times bigger than our sun. They burn out quickly and explode in the flash of a supernova. Billions of years later, an orbiting satellite called Swift is in position to capture that flash of light. Swift is the eyes of an international group of astronomers. Within 30 seconds of detecting a flash, it sends out an alert via mobile phones, pagers, and emails.
Adam, Mike Ford calling. We have a GRB detection. Please meet me at the observatory and call the GRB team.
The astronomers scramble to their telescopes. Speed is vital. They have to catch the light beam if they are to probe the dark secrets behind these distant disasters. First, they determine how far it has traveled, give it a name, and pinpoint its birth galaxy.
Then we're going to need to move the dome. Casey?
By analyzing the light, they have gleaned the distinctive signatures of black holes being born. The most distant are the earliest generation of primordial monsters.
We could be forming the seed of the supermassive black holes that we see in galaxies today very early on, when the very first objects form in the universe.
We can now, with our big telescopes, look back in time, and sure enough, what we find is that at the same time when the galaxies formed, also the black holes formed. It may very well be that they needed each other.
This computer simulation shows how our Milky Way galaxy was born. It grew over billions of years from a swarm of smaller galaxies, smashing together, merging. In a cosmic dance of death, the infant galaxies swirl around and orbit one another, gravity pulling them closer.
If another galaxy comes too close, they will each feel each other's gravity. What started out as a stately ballet of stellar orbits moving around the center of their galaxy has now become this maelstrom. There's no other way to say it. Galactic cannibalism, that's what they're doing. They're dining on their neighbors, eating entire galaxies. Well, for every galaxy you eat, if that galaxy has a black hole in its center, it's going to eat the black hole. And the black hole will work its way down to the center of the large galaxy, making the center of the galaxy bigger as well as the galaxy itself.
As galaxies swallow each other, the black holes at their centers merge and grow.
And there was an epoch once, about 1, 2, 3 billion years after the Big Bang, when in fact galaxies were forming, or at least they were tremendously more active than now. And at the same time, black holes already existed, had formed, and were fed at tremendous rates, producing very powerful quasars.
Quasars are bright beacons of light at the centers of distant galaxies, where feeding black holes shine brighter than anything else in the universe. The Hubble Space Telescope peered into a dormant quasar in a nearby galaxy called M87. It found a tiny central region where gas is heated to tens of millions of degrees and whipped by gravity to millions of kilometers per hour.
What it became obvious was that there was a tremendous amount of mass in a very small volume. But that mass was very unlikely to be stars, like those stars that we see in our galaxy.
Astronomer Brian McNamara believes giant ravenous black holes can have a profound effect on the surrounding galaxy and beyond.
How can we get an offset?
180?
180, 180, same direction.
We are setting at 360, 360. Guider is locked up.
McNamara is studying a trail of devastation left in their wake.
Isn't that amazing? All of these other galaxies are gravitationally bound to this galaxy cluster. So they're all buzzing around this giant galaxy like bees buzzing around a hive.
These clusters are the product of galactic cannibalism on a cosmic scale. This computer simulation shows how a galaxy cluster evolves in a dense region of the universe, tens of millions of light years across. Hundreds of galaxies form, then swarm toward a common center. A central galaxy swallows them up. As it grows, so does the black hole. McNamara is searching for the monster's paw print.
So that's a giant galaxy sitting in the middle of a cluster of galaxies. So the idea is that that's a big galaxy, and right down at the center you can't see it. We think there's probably a black hole that's got a mass that approaches 1 billion suns. It very recently, in the last several tens of millions of years, gobbled up a lot of matter, and it caused a huge eruption.